Welcome back to the office. I want to talk about the conditions for a subgroup. And the reality is we've already talked about this. So I'm going to return back to our first example here a moment. See if I can go back far enough, classify as subgroup or not. So in this particular example here, 3Z, we said that it is a subgroup. We were able to verify that there's closure under the binary operation because that's what's required, closed under the binary operation. But we said that the associativity is inherited from the original group itself, Z under addition. So we have closure, we have associativity. We just need to verify identity and inverse, right? And we kind of discussed. We didn't write down, but we discussed why identity and inverse exist. Now, when you approach a homework problem that says verify that this is a subgroup, well, yes, you're going to have to verify closure. You're going to want to point out that associativity is inherited. It's a good idea to show that anyway. If you don't, right, it's assumed. That's kind of what our theorem is going to say. But then we also need to show that the identity belongs to that subset and that inverses belong to that subset. So that way we have the characteristics of a group. And that's exactly what our theorem here says. So a subset H of a group G is a subgroup if and only if we have these three characteristics. Okay, closure under the binary operation, identity is in the subset, and for each element of the subset, its inverse is also in the subset. So closure with respect to inverses there as well. I'm not going to go through all of that because we essentially did that already. I just want to remind you that when you approach a problem to verify that something is a subgroup, you do need to demonstrate all three of these things, whereas we only did this one in our initial example, and we talked about these ones. Okay, but you actually need to show all of them when it comes to the homework. All right, so that's it for this video. I'll see you guys back here in the office in just a little bit.